This is SAT Practice Test 6 from the Bluebook, full math section, 70 minutes on the clock. I'm going to finish in about half that time, get a perfect 800, and break down every shortcut and Desmos trick as I go along. Between modules, I'll show you the tool that I built to help you do the exact same thing. You do not need to be a math genius, you just need enough reps to recognize every problem type on site. Let's go. Module 1, let's go. Open up Desmos, make it a little bigger. We don't really need it for the first one. This one says bird species can fly at an average speed of 16 meters per second. When it is in continuous flight at this rate, how many meters would it fly in 4 seconds? So this is pretty simple, just 16 times 4, which is 64. It's, again, 16 meters every 1 second. So if we have 4 seconds, just multiply by 4. Next one, line R has a slope of 4 and passes through 0, 6, right? So this is just basic equation of a line. Slope 4, remember, where's our stuff with lines? Right here, you have just two parts, your slope and your y-intercept, right? And that's both the parts they give you here. Slope 4, that's 4x, and y-intercept 6, so D. Next one, which expression is equivalent to this? So it looks like all they did was factor out a GCF, right? So the GCF here, you can probably tell is x cubed, so it has to be B. I'm gonna show you another way real quick. It's kind of cool for these equivalent ones if you're not sure, right? Sometimes they're faster to do algebraically, but here's what you could also do, right? You could type this into Desmos and it'll draw a picture for you, right? Equivalent means, right? This is a key word you want to remember. It means one of these has to be the same. So this is a good strategy to know when it's like a harder problem, right? Where the algebra might not be as obvious. You see, if I put in answer choice A, that's not the same as the original one. So that's not equivalent. But you see, if I change it to B, then 5x squared minus 6x and then plus 8, you see, this is the same exact graph. So that's how you can verify an equivalent one if they're the same, just using Desmos, right? Good to know. Next one, they give us an equation, x plus y equals 1440. Number of minutes of daylight, x, so that's what x is, the number of minutes daylight, and the number of minutes of non-daylight, y. If this day had 670 minutes of daylight, so what did they tell us? They told us x, so you see, I can just plug that in for x, and the question is going to be what's the amount for the non-daylight. You can subtract those yourself. You can put it in Desmos, and you see you can just click on y, and it's going to be 770. Okay, next one. Scott selected 20 employees at random from all 400 employees. He found that 16 of them in the sample are enrolled in exactly 3 professional development courses this year. Based on Scott's findings, which of the following is the best estimate of the number of employees who are enrolled in exactly 3 professional development courses? Okay, so what this is going to be statistical inference, right? We got that somewhere here. All right. So sometimes what they want you to do is extrapolate, right? So you can just kind of create a proportion. So here we know we picked 20 employees and it says 16 of them are enrolled, right? So that's your fraction. You could say 16 out of 20. And then we want to know how much is that out of the total. You can set up a proportion like that in Desmos. Just click on the answer, then 320. You'll see that. That's a common statistics question. Next one says, which equation has the same solution, right? So this one's kind of easy. You might be able to just eyeball this. If you get rid of the 7 by dividing by 7, it's this. But I'll show you in Desmos how you can do it as well. Remember in Desmos, or on the Bluebook, keyword solution, right? Anytime you want a solution, if you just type the equation in, you see, I see the solution for this is 6. So now one of these has to have the same solution, right? So you see when I type in A, right, that gives me the same solution, right? So that's how you could also know, whereas like, you see if I typed in B, right, it gives me a totally different solution. So you probably don't need Desmos, but that's how you can do it in Desmos. Next one here gives us an equation. This is very common. You just get kind of an equation and you have to solve it for another variable. Even without reading this, you see, I know what they want me to do. They want me to solve for C. So to solve for C, I just move 7 to the other side. That's A. That one's pretty simple. Next one here. It says function P estimates that there were 2,000 animals in the population in 1998. Each year, the number of animals increased by 3%. That's going to be important. Which function gives this, right? So these are all examples of exponential functions. You kind of want to know what that is, right? So where's our exponential equation? Here it is. It has 2 pieces to it that you got to know, right? There's this number out front. That's the y-intercept. It's the initial value. That's why they all have 2,000, right? It started with 2,000 animals. The thing we have to see is the one I highlighted. It said that it increased by 3%, right? So inside here in our exponential equation, right, it's always we write 1 plus or minus the percent, right, when it talks about increase or decrease by some percent. So that's going to be 1.03, right? If you don't know what the decimal is, just write 1 plus the percent over 100, right? And it'll just give it to you. That's it. Next one, an equivalent one. So you see here, you could do the algebra, but I'm going to do that trick I showed you earlier, right? I can just type this into Desmos and it'll draw the graph. And then I'm just going to see like literally which one of these answer choices is the same thing, right? So you see if I enter an A, that's not the same, right? So then I just got to change it a little bit, change plus 14 to plus 96. There it is, right? That's the same thing. So turn that graph off, right? If you click on the color, you can see the green one, original one underneath it. I like that. I find it really useful. Okay, next one. An egg is thrown from a rooftop. The equation h equals negative 4.9 t squared plus 9t plus 18 represents a situation where h is the height above the ground in meters, t seconds after it's thrown. What's the height from which the egg was thrown, right? So this is a quadratic equation. You'll see this with quadratics, right? I got something here. Quadratic interpretations. When you have a quadratic and it's like a word problem like this, you see there's 3 key points that you want to know. And based on the wording, you kind of want to know like, what are they asking you for, right? They can ask you for the y-intercept. That usually represents some initial value, right? They can ask you for the vertex. The key that you'd want the vertex is like the max or the min. They'd mention that. When's the maximum or minimum? And sometimes they ask you for the x-intercept. The key phrase for that is like when it hits the ground, right? Object's going to go in the air. It's going to return to the ground. So here it wants to know what was the height from which it was thrown. That's talking about like the initial value, right? And so when a quadratic is in this form, right? This is our standard form. Let me pull up quadratics again. 3 forms you want to know. When it's in standard form, you know the y-intercept is just the c. So I know this is 18, right? But if you didn't know that, you could just plug this into Desmos and just click on the y-intercept. But basically, you just want to know, based on that question, it's asking you to find the y-intercept, right? So make sure you know those 3 common questions that they'll ask you for interpretations. Next one, 11 here, pretty simple. You type this into Desmos, this equation. And again, anytime you type an equation into Desmos, it'll tell you what x is. Sometimes you can't click on it, but you see if I zoom in on it, I know x is 8. They want to know what's 6x, so 6 times 8, 48. Next one, the relationship between 2 variables x and y is linear. Then we know it's a linear equation. It says for every increase in x by 1, the value of y increases by 8. When the value of x is 2, the value of y is 18. Which equation represents this? I've seen this before and a lot of students get this wrong, and it's actually really simple, right? There's 2 key things, 2 individual things that would just let you know what's the correct answer. I think the most obvious one is literally this one, the third sentence. It says, when x is 2, y is 18. You just need to plug in 2 and see which one gives you 18, right? So it wouldn't be A. If I plug in 2 here, it's 4 plus 8. That's not 18. If I plug in 2 here, it's 16 plus 2. That's 18. So simple, right? Just read. The other thing, the second sentence is describing slope, right? So it's telling you for every increase in x by 1, the value of y increases by 8. Remember for slope, right? For slope, we said this. It's kind of like we can write change in y, right, over change in x, right? So you see, that's literally what they're describing. They're saying like y is going to increase by 8, and for every 1 increase in x, right? So our slope is 8. So that's the only one with a slope of 8. So either the second sentence, third sentence can just tell you it's C, and I think the third one's the easiest one. This one, we see this a lot. How many solutions does it have, right? Just type it into Desmos, right? And you can usually see, right? So here we don't see anything, so it's 0 solutions, right? Sometimes you got to be careful because, you know, if you don't see anything, it could actually be infinitely many solutions, right? So the reason I know here it's not infinitely many solutions is that infinitely many solutions, they got to be the same thing on both sides, right? I think we have that somewhere here as well. Here it is. Infinitely many solutions, you see, as equations, right? It's literally got to be the same thing on both sides, right? But you got to be careful because you see, if I write that example in, right, Desmos isn't going to show you anything, right? So sometimes people might think this is 0 solutions. It's just a weird Desmos quirk. When it's infinitely many solutions, it also won't show you anything, right? So just be careful for that, right? That's a common trap. Next one, we got these box plots, right? It says 2 box plots are shown. What is the positive difference between the ranges, right? So this is our statistics stuff. So statistics, here's your box plot. You got to know this. It's kind of a silly thing, right? It shows you 3 important things. The minimum, the maximum, those are the whiskers at the ends, right? Sometimes it's called box whisker plot. And the line in the middle is the median, right? So here we got to know range, right? Desmos doesn't calculate range for you. You got to know range is taking the largest value minus the smallest value. So here I want to find the difference between the ranges for the two classes, right? So for class A, right, it's going to be the highest was 5, the lowest was 0. So it's going to be 5 minus 0, which is 5. And for class B, right, that's going to be the highest is 10, the smallest is 1, so that's 9. And then I got to take a difference between their ranges, right? So it's going to be 4, right? Next one, the length of an edge of a base of a right square prism is 6 units. The volume is 2,880 cubic units. What's the height? So volume, surface area, right? They do give you kind of like a worksheet for this. Let me, sorry, not a worksheet, a formula sheet, right? The reference sheet, it's right here actually, right? So the thing is though, they don't give you like, they like to use this one. It's called a rectangular prism, right? But sometimes like here, they'll tell you like it's a square prism, right? So the only difference there, where did it go? I have kind of these drawn out, right? Again, this is the most common one, and you should be able to derive these other ones based on that if you just understand the differences. Rectangular prism just means all 3 dimensions are different, right? Length, width, height, right? Here's your volume, they give you that. They don't give you surface area, so make sure you kind of know how to like come up with the surface area equation. It's just the area of all the sides, the 6 sides. But then what they have is like 2 iterations of this, right? You can have a square prism. What that means is the base is a square, so 2 of the sides are the same. This is how your volume and surface area would change. And then you could also have a cube where all 3 sides are the same, right? So it's the same object you see, just 3 different sides, 2 different sides, or all the sides are the same, right? So here I know this is my volume formula. It's just x squared times h, right? So let me put that into Desmos. V equals x squared times h. And you see, they're telling me these things. They tell me that, you know, the edge is going to be 6, and they're telling me that the volume is 2,280, and they want me to figure out the height, right? And Desmos can calculate it. You just need to make height x, right? When you have an equation, the unknown has to be x for Desmos to solve it. There it is. I can click on it, and it's 80. Next one. We got this, it's an exponential equation. You should notice it by the graph, but they also kind of tell you here it's an exponential equation. And basically we got to come up with the equation, and their question is, what's this b value, right? Easiest way to do this, you just do an exponential regression, right? So take 2 points, put 2 points in Desmos, right? I think here, let me find 2 kind of nice points. It looks like 460 and it looks like 640, right? So 460, 640, and I just hit my regression button. Change it to an exponential regression, and you see this is exactly in that form that they want, a times b to the x. And so this is the b value, right? It's a 0.81. So closest, right, is going to be 0.83. Next one, simple trig problem, right? So trigonometry, you just got to make sure you kind of know your SOHCAHTOA, right? So here they want cosine. So here's our angle. So adjacent is going to be 11, hypotenuse is 28. You can literally answer it like that, 11 over 28, right? You can put it in as a decimal as well. We do not need to find the opposite side. Sometimes you do, here we don't, but you just do so with Pythagorean theorem, right? Next one, what's the positive solution, right? If you kind of see this as in factored form, you can see that the solutions are gonna be -2, +5, and -9, right? But if you don't know that, right, just put it in Desmos, right? You will literally be able to see all the answers, right? And again, sometimes you can't click on it, but if you zoom in on it, like this is the positive one, right? We zoom in on it, we see it's 5. Next one here. This is gonna be similar triangles, right? When you see 2 triangles, it's probably similarity. That's like one of their favorite things to ask. Let me just kind of copy this over so we can draw on this. So here, okay, so now I wanna kind of like fill these things in, but here's how I know it's similar, by the way, right? You see these angles are the same because they're both A, right? And then these angles will be the same because they're vertical angles, right? And then finally, this pair has to be the same. But that's why, like, and sometimes you'll see a question on the test, they'll say like, prove they're similar triangles. You just need to show 2 angle pairs are the same. That's a proof for, you know, similarity, right? So here's that one. So those are our pairs, right? Okay, let's fill this in. So they tell us that YQ is 63, so that's here. WQ 70, so 63, 70, 60, and 120. Let me see if I remember all that. 63, 70, 60, 120. So over here, 63, 70, 60, and 120. And the question wants us to figure out, you know, YZ, which is X, right? So this is like what we're solving for. So all we're gonna do is set up a ratio here, you see, and this is why like having them marked up, you know, is helpful because you just need to, it doesn't matter how you set up the ratio, you just gotta be consistent. So for instance, I could do x over 63 in this triangle, and that would be the same as doing 60 over 70, right? So I just put that into Desmos, right? And Desmos, right, if I zoom out, again, this is another proportion, it'll just solve it, it's just 54. Okay, next up, we got a function here. So you see, if I type this function into Desmos, most things with functions is just gonna be a Desmos problem, right? T minus x. This is my function, and the question, let's just go to the question real quick. It wants to know g of 0. If you type a function in, you can then just ask it, like here, I can ask it g of 0, right? It's not telling me g of 0 because there's an error, and it's important you to understand, like, why are you getting that error, right? So the error is it doesn't know what t is, right? That's why it's not giving me an answer. So what I got to do is I got to figure out what t is, and then when I know what the value of t is, I can have Desmos just tell me this, right? So how do we figure out t? Well, there's got to be other information, obviously, right? And that's the whole point of this second sentence. You see, they tell you that it's going to pass through this point 24, 0. This is really subtle, and a lot of people miss this, right? What you got to know about a point is just an x and a y value, right? So what I can do is I can plug this in for for x, the 24, and plug this in for 0, the y. I was plug in 0 for y, sorry. So it would look like this, right? If I kind of go back to this one, it'll be 0 equals 24 plus 14. I'm plugging it in for x, and then t minus 14, right? And then Desmos will solve for t. Remember, you just got to always, like if you have an equation, your unknown's got to be x. So I just changed t to x. But this is my value of t. It's 14, right? So now you see I can go back here. I know t is 14, and I can ask it to do g of 0. And then, wait, was that? Let me double check that. Was that correct? 0 equals 24 plus 14. And then, oh no, it was wrong. I made a typo, right? So I just kind of caught that. So t should be 24, actually. I think I plugged in 14 over here. Yeah, it's 24. So we do that, and then we do g of 0, right? So small mistake, don't make that mistake, 336. But that's it, find your t, then you can answer have Desmos just give you this question, right? So I hope that makes sense with that little mix up I had. Next one here, number of zebras in 2018 was 1.27 times the number in 2014. People are going to get this wrong, but there's a really simple way to do this. It's just, you got to read this first sentence and realize they're giving you an equation, right? So here's my equation. They're telling me basically like the population 2018 is equal to, that's like the keyword was, right? And then 1.27 times the population 2014, right? That's my equation. Next sentence, it says, gives you another equation actually. It says, if the number of zebras in 2014 is p% of the zebras in 2018, right? So see population 2014 now is, that's your equals, p%, so make that p over 100 times population 2018, right? Finally, the question is, what is p, right? So you see, if you write this, you kind of see like what you have to do to basically solve for p, right? If you rearrange this equation, you would take the population 2014 divided by the population 2018 and multiply by 100, right? This is going to be like what gives us this value for p, right? So basically what I need to solve this problem is I need to know these two populations, right? And they didn't tell you anything about it, but you see it's this first equation that allows us to do that, right? If you understand equations, to get population 2018, you see, it just depends on what the population 2014 is, right? So I can say, let, population 2014 equal 100, and then my population 2018, that's simple math. That's why I picked that as 127. So you see, now I'm going to do this calculation, right? I'm just going to replace, the numbers with what we have, right? So it's going to be 2014, that's 100 over 127 times 100. Here's my answer. It's 78.7. It says round to the nearest whole number, so we'll round to 79. In my opinion, this is a pretty tricky problem unless you take this approach, right? And you kind of know to do this through practice, right? So that's it. Just do more practice problems, see more practice problems. These things become more, obvious. Last one here. This one looks pretty simple. They give us a circle, and, with circle equations, you can type these in, right? So you see, if I type this in, they already drew it for us, but if I type this in, I'll see that same circle. And the question just wants, it says circle B not shown is the result of shifting it down 6 units and increasing the radius as 2 times the radius of circle A. Just try these, right? You'll literally see, like if I put in answer choice A, right? Like people get this wrong, but there's no reason to get this wrong. If I type in answer choice A, I can see that answer choice A, the circle moved down and the circle got bigger, right? It's gonna be A. You can try the other ones, right? Like I'll show you B, but basically you'll see that, none of the other ones move down and get bigger, right? Like for instance, B gets smaller actually, right? Let's put this in and you'll see. So this one, it moved down, but it got smaller. We don't want it to get smaller. And then C gets bigger, but it actually moves up, right? So here, let me show you that one as well. So get rid of these 2's and make this over here 4 times 9. You see that moved up, right? So you just try them and see like which one literally just moves down and gets bigger. That's it. That's it for module 1. Not too bad there. Quick break before module 2. Want to show you something I built. Here's the reality about SAT math. Watching someone else solve problems does not make you better at solving them. What makes you better is doing hundreds of them yourself until you stop thinking and just solve. When you've done 50 linear equation problems, the 51st one isn't even a question anymore. You just see it. That's the level you want to be at before you walk in. All of these are obvious to me just because of practice. That's why I built Sigma Prep. Every SAT math topic organized by difficulty. You pick a topic, you practice. Every time you get a question wrong, there's a video explanation of me breaking down exactly how to solve that specific problem. You watch it, you retry it, you lock it in. No more getting stuck and wondering what you did wrong. Let me show you real quick. Say I jump into this topic here, I get a question, I answer it. If I get it wrong, right here, video explanation. I can watch exactly what I would do, then try it again. Every topic works like this. Every topic is free to try. Jump in, start practicing right now. And if you want to know where your weak spots are, take the diagnostic quiz first. You'll come out knowing exactly what to focus on. Bottom line, if you put in real reps with real feedback, there's no way your score doesn't go up. sigmaprep.io, link in the description. Back to module 2. All right, module 2. Let's open up Desmos, go through this one. Manager is responsible for ordering supplies for a shaved ice shop. The shop's inventory starts with 4,500 cups. Estimates 70 of these cups are used each day. Based on this estimate, in how many days will the supply of paper cups reach 1,700? So what this is basically just a linear equation, right? Where's our linear equations here? There it is, it's down here in the corner. Basically, you know, they're giving you the slope. That's the 70 cups used each day, right? Keywords for, slope is the word per and each. And then it told us we're starting with 4,500 cups. That's your, y-intercept, right? So basically I could write this. I could say like, y equals, negative 70x because we're losing paper cups in 4,500. And I basically want to know, when will it be 1,700, right? So this is my equation. You just kind of write that in and you see that'll be in 40 days. Okay, another triangle question. They tell you measure of R is 63. What could be S? Well, in a triangle, we just know that it has to add up to 180, right? But we only know one angle here. Okay, yeah, so this is actually simple. So it can't be 180, obviously, because it has to add up to 180. And it can't be either of these two, because you see, if I do 63 plus 126, that's more than 180. And if I do 63 plus 118, that's more than 180. So that's why it can't be B or C. But you see, if I did 116, it'd be a weird looking angle because the final measure would be a degree of 1. But yeah, technically, this is the only one that could be it. Next one here, inequalities. These are pretty simple. If you see inequalities, just throw that into Desmos and you'll get like this shaded region. The one that has the solutions, right? Solutions just have to be in the shaded region. So easiest way, what you do next, just throw in this table and put in your points. You see, if I put in 219, that's good. That's in the shaded region. Let me check the next one. That's also in the shaded region. Good. And last one, that's also in the shaded region. A has them all in the shaded region, right? So it's going to be A. I'll show you, like, for instance, like if I go to B here and do 2,8, you see that's not in the shaded region, right? So you just want them all in the shaded region. And you got to be careful. Sometimes they'll put them on the line, but if it's a dashed line, you can't be on the line, right? Next one, function question. I think this is the first kind that we saw here in this test, but these are pretty common. Usually they'll tell you like what to plug in for X, or like in this case, they want X and they're telling you f of X is 5. So you see, I can literally, get rid of my emojis there. I can literally just replace f of X with 5 and just click on it and it's 3, right? That should be a freebie. Next one, during a portion of flight, an airplane's cruising speed varied between 150 miles per hour and 170 miles per hour. Which inequality best represents the speed? There's literally nothing to do here. They're literally telling you speed, S, has to be between these two numbers. Next one, the graph models the number of active projects a company was working on X months after November 2012, right? According to the model, what is the predicted number of active projects the company was working on at the end of November 2012? There's really not really any math to do. You just got to understand the situation, right? They didn't mark the x-axis and y-axis, which makes this tricky, so you got to understand it. You see, I highlighted x, right? Whenever I kind of read a variable, I kind of highlight it as a habit just for it to stand out. X-axis represents months after November 2012. The y is the active projects, right? So the question's asking you for how many active projects. We got to answer with a y, but the thing is you got to know for like what value of x, right? And that's why this is the most important thing. It says X is the months after November 2012. So if they're asking you, you know, at November 2012, right? Well, that's 0 months after November 2012, right? So we want to go to where X is 0 and we see the Y is 5, right? So no real math to do there, no Desmos. You just got to read and be careful reading, right? Linear function. Okay, we just got to get a linear function. Easiest way, this is every test. You got to know this. Add the table. Put in your 2 points. Now, the weird thing about this is how they wrote the points. This is function notation. You see h of x, right? You got to know that this thing in here is x and this is your y. So you see my points 28, 15, 26, 22. Smash the regression button. Here's my equation, negative 3.5x plus 113, right? So it's one of these. And if you're not sure, it's d. But if you're not sure, you see, because Desmos will give it to you as a decimal, just throw that fraction in and you can see it doesn't match that decimal, right? 8, okay. Another linear relationship. We're literally going to do the same thing, right? So if I put these in, 3, 174, 5, 284, and finally 10 and 559, right? You see, it writes the equation like this, right? So you kind of have to understand like what's your x and your y. So here, cars is x, right? So I want to replace, right? I'm going to replace x with c because that's what the variable they're using, and then y is the passengers, right? And what I got to do now is I got to kind of rearrange this equation so it looks like one of these, right? So it's definitely, you know, you see right away if you replace those variables, you know it's A or B because it's got to be 55C, right? And so what they did is they moved the P over to this side, so it's 55C minus P, and then you got to move the 9 to the other side, so it's negative 9, right? So you can take that regression thing again, just swap the variables and rearrange it a bit, right? Next one, this one's easy, just wants the solution, right? Those are freebies. The thing is, you got to know about Desmos is if you type it in like this, you're not going to get solutions right away. And that's because, again, when you have an equation, mentioned this a couple times already now, I think your variable has to be x, right? So just swap those w's to x. You see, these are our solutions. Now I got to see which number matches one of these, right? So if I put in a first, 2 square root 19, let's see, that's not this number. It's this number, but it's negative, so that's not right. If I try 2 square root 17, right, that's not that number. If I try square root 19, that's not it either, right? And so finally, negative 6 plus 2 square root 19, let's see, yeah, that finally matches that number, right? So that's it, just process of elimination. Next one, also easy. It wants to know what's the y-coordinate of the y-intercept, right? If you got to find intercepts and they give you the equation, just throw it in, right? You do not have to change this. Sometimes people waste time doing algebra. You do not need to change it. You can enter it just like you see it and just click on the y-intercept. Let me just make sure, it's a kind of a weird looking number. Let me just make sure I entered it correctly. 3x over 7, negative 5y over 9, plus 21. All right, so that's it. I mean, it looks a little weird, but as long as you didn't type it in wrong, right, it's going to be correct, right? So 37.8. Next one gives us a graph. I always love these. People kind of get these wrong. I'm not sure why sometimes. Again, it just kind of comes down to unfamiliarity, right? But there's always a simple way to do things, right? They're literally showing you the picture of what it looks like. You just got to try these answer choices and see which one looks like the same picture, right? So just trial and error, but there's no reason to get this wrong and it should be pretty quick, right? You see, if I type in this doesn't look like this picture, right? They're not intersecting together at 8, right? So that's not it. A tip, again, you don't have to erase everything. Sometimes people erase everything. Usually they're pretty similar with small changes. So you see, next one, I just swapped 2 signs and that's it. This is wrong because these are going up and not down, right? So it's not A, it's not B, right? Let's try C. So C is 4x minus 10y, right? Equals 32. And then this one's negative 8x plus 10y equals negative 64. Okay, so again, these are going up, right? Wrong direction, but at least they're intersecting at 8 now, so it's not C. So it's got to be D, but let's just kind of confirm, right? You should confirm on an actual test, right? Don't assume, because you could have typed something else wrong and you wouldn't have noticed it. But you see, now they're both going down. They intersect at this point A, so that's correct. Another system question, right? Systems is just Desmos, just like that last one, right? So just type this in, and this time We're gonna wanna figure out the X and Y value, right? So these look weird, but that's okay, it doesn't matter, just type it in, right? X minus 2 plus 4 times Y plus 7 equals 442, right? Zoom out, find where they intersect, here it is. This is your X and Y, right? They want you to do 6 times X minus 2, right? So I just need my X value here, right? So I want to do 6 times, and then in here, minus 2. That's it, X minus 2 there, you see, and we get 1677. Next, gives us a function, wants to know the minimum value. That's also a Desmos question. Like if they want intercepts, maximum, minimum values, those are all things you can click on. You see, you type this in. Now, the mistake people are going to make, you see, is they won't know what number to ask for. So here's the thing, right? Here it just says minimum value. That's the Y value, right? When they want X, it will say for what value of X, right? So since it doesn't say that, I know they want the Y value, right? So 1728, that's it. Next one, how many solutions does this equation have, right? So you type this in, negative 49x, negative 98x, right? What do we see? You see one line, right? So there's one solution, right? The solution is 0, right? So we saw that in the first one, it had no solutions, it was a quadratic, right? But this one there has one solution, right? Next one, another function question, right? We saw something like this also in module 1. You type this in, right? X times X minus 2 times X plus 6 to the second power, we get our graph. And they want to know this, they want this function, g of 7 minus w, right? So you can type that in, but you're going to get an error. So again, we want to know why, and it's because when you have functions, again, Desmos wants the variable to be x. So you see, if I instead just swap that to g of 7 minus x, right, I can see both graphs. I do not want to look at the first one, I'll turn it off. And they want to know like when this is 0, well, we can just click on the zeros, right? There are all your zeros, 5, 7, 13, and it wants the sum of that, right? So if you just kind of add those 3 numbers together, we get 25. That's pretty simple. Next one. A grove has 6 rows of birch trees, 5 rows of maple trees. Okay, so this is a probability question. Normally when you have probability, right, let's talk about that first, right? This one's a little annoying. Normally when you have probability, it'll be like this. It'll be table probability, right? So you'll just have all the numbers in front of you and you just got to read it carefully and just kind of know what to pick, right? Here, this is annoying because they do not give you the table, so you got to kind of like write all this out. So we got birch, we got maple, right? So birch, they say there's going to be 6 rows, right? Maple, there's 5 rows, right? And then it says each row of birch trees has 8 trees that are 20 feet or taller, 6 trees that are less than 20 feet. Okay, so then for the birch, greater than 20, it's going to be 48 trees, and then less than 20, right? It's going to be, it was 6 rows and 6 trees, so it's going to be 36, right? I'll put this all in a table here first. I'd normally just write this out on paper. I'll go to the graph pretty soon and we can kind of like simplify this, but that's what we want to know. And then for the maple, you know, you got 5 rows, right? And so greater than 20, they said each row has 9 trees that are greater than 20. So 9 times 5, 45 trees. And then for less than 20 feet tall, right, it was 7 trees that are shorter than 20 feet. So that's 5 times 7, so it's 35 trees, right? So let me put this in a nice table here for you so you guys can kind of like visualize this, right? So let's go over here and draw. This is what, normally you would just get this, right? So this is just what's making this problem like super tedious. Normally you'd have all this information already for you, right? Let me just draw, you know, this. So what's going to happen here is we're going to have, you know, all our data. Yeah, this is annoying. They normally don't do this, honestly. I think this is like one of the only ones I've seen that kind of does this. So you got these 3 things, right? And let's put this in. So we got maple, we got birch, and then, you know, you have like total columns as well, right? And then up here we had that like they were greater than 20 feet. We got that they were less than 20 feet. And then we got the total again, right? And so for maple, we put this in maple. 45 were greater than 20, 35 were less than 20. So it'd be 45, 35, right? And then over here, we add those up and that's 80 trees. And then for birch, it was 48 and it was 36. And so we add those together for the total of birch and we get 84. And then you can add the total, there's a total of 164 trees. Over here, it's 93 of them that are greater than 20 and 71 that are less than. So we got our table now, right? Now we can answer the question finally, right? So when you answer probability, you just gotta be careful, because like sometimes people make a mistake. They use like the total. A lot of times they don't want the whole total, right? They'll kind of specify. So like here, you gotta read this carefully. It says, what is the probability of selecting a maple tree? So we want a maple tree given that it's 20 feet or taller. So you see, they only want this, right? Let me highlight it. They only want the ones that are greater than 20, right? So you see, our fraction is going to be out of 93, because 93 are greater than 20, and we want 45 of those, right? So it's going to be 45 out of 93, throw that in, reduce that fraction, there's your answer, right? So kind of an annoying, tedious problem there, but that would be it. Next one, geometry problem. Rectangle is inscribed in a circle. We got to go back to drawing, right? And it says each vertex of the rectangle is on the circle, okay, on the circumference. Diagonal, all right, let me just go sketch this really quick, right? So geometry is a little annoying sometimes because you do have to kind of like sketch and things like that. So let's see, here's our circle. Let's throw in a rectangle here if that's possible. Yeah, it looks like that works, something like that. And they're talking about the diagonal, right? So the diagonal, you know, you want to understand here, one of the key things is that there's always like going to be a relationship when one shape is inscribed in another one. Here you kind of want to see, I'll write it down here, the diagonal is the same thing as the diameter of the circle, right? Because if you go from one end to the end through the center, that's going to be it. So what else did they tell us? They told us that the diagonal is twice the length of the shortest side. And then they tell us the area of the rectangle, and they want to know what's the diameter. Okay, so what's going on again? They said that this diagonal is 2 times the shortest side. So if this is the shorter side, let's call that x, right? And then the question is, right, they told us the area of the rectangle, right? They said area is 1089 square root 3, right, for the rectangle. So if I'm thinking about this rectangle, right, to calculate area of a rectangle, right, we know area of rectangle is length times width. So this side could represent the width, but I need to represent the length, right? And what makes this problem tricky is you might not recognize it, but what this is, it's a 30, 60, 90 triangle, which they kind of give you right here, 30, 60, 90. Because only in a 30, 60, 90 triangle is the hypotenuse 2 times one of the other sides, right? So if you kind of know that, then you see, I know that, you know, this side over here, the missing side, which I need to know is x square root 3. And then I can just put this in Desmos, right? And it'll find x, because I know the area is 1089 square root 3, and I can just say that's the length, so x square root 3 times the width, right? And you see, it'll just solve for x, right? I can't click on it, but if I zoom in on it, here, hang on, I have xx there, that's why. So let's make this a little smaller. Yeah, I should be able to click on it. It's 33. Now, just be careful. One last trap is, you know, sometimes people do all that, right? And they answer with 33. What was x again, right? If we kind of go back, x was this like shorter side of the rectangle. Their question in the end was they wanted to know, right, what's the diameter, right? And like I said, that was important earlier on to know diagonal's diameter. So we just do 2 times our 33, and that's just going to give us 66, and that's it. But these are annoying at the end of the test, these geometry ones, because you have to typically sketch something out, right? And if you don't sketch it out correctly, you're just kind of, you know, well, you're not going to get it right probably, unless you just guess it right. Next one, this is a percent problem. Percents, you know, we saw this, it wasn't really percents, but there was the one about the population of the zebras or whatever at the end of module 1. Here it's kind of the same thing. This is an equation, right? You can just write this as an equation. A equals, is your key word. Remember, is your equals. It separates the two sides. 2,241%, just throw that over 100. Of means multiply. Of what? The sum of b plus c, right? I can literally just kind of write that. And then this is also an equation. B equals 83% of C. So that's going to be B equals 83 over 100 times C. And finally, even the question itself is an equation. It says what percent of B is A, right? So if you think about it as like a percent, it'd be like this. What percent, so that's what I don't know, of B, so times B, is equals A, right? So you see, if I want to solve for X, right, what do I have to do to solve for X? X is basically going to be this. You see, it's going to be A divided by B times 100, right? So that's what I want. So here's a quick way. You see, I'm just going to get the answer. You'll see it pop up because you got to understand these dependencies now, right? You see, to get A, you would need to know what B and C are. To get B, you would need to know what C is. So you see, I just need to tell it what C is, and it's going to calculate B, then it's going to calculate A, and then it's going to give me my answer. 4,941%. And you can see, watch this, if I change the value of C, these numbers change, but the final answer doesn't change, right? Because it doesn't really matter what A, B, C are as long as we have the right relationships. Next one here. This is a common question you see at the end of the test, and there's a really quick way to solve this, right? They give you these two linear equations like this, right? And you can graph one of them, right? So like this first one, there's no issues, it'll kind of graph it. But the second one, if I enter this into Desmos, right, it's not gonna like it. It's gonna have a problem with it, right? And the problem is gonna be, it doesn't know what P is, and that's the question. If it has no solution, what's P? So here's a really cool way. You add P, you see, and now that it knows what P is, in this case like 1, right, it shows us what it looks like. But this is obviously not no solution, right? For no solution, we want them to be parallel. So you can just drag this slider along, right? And you see they're kind of starting to become more parallel. And so it looks like 3.5. So you go over here, just zoom out, make sure they remain parallel. I think if you go out to like 100 in each direction, they're still parallel, you're good to go. So yeah, 3.5 looks good. Otherwise, what you have to do in this case, if you want to do it like more algebraically, is, you know, this just means they're parallel, which means they're going to have the same slope. So you can algebraically just solve for the slope of each one and equate them to each other, right? That's your alternative. Next one here gives us a table, and it tells us we got this function g of x. Okay, g of x equals f of x over x plus 3, and f is a linear function. Ooh, okay, and they want to know what's the y-intercept of f of x. So first, right, understanding what they gave you. You know, they're telling you that f of x is a linear function, right? Our linear function is just mx plus b, right? And so this is really what g of x is. And they want to know like what this b is going to be, like the y-intercept of f of x. So this is actually a tricky problem, right? You know, the easiest way to do this is doing a custom regression, which is a little bit, you know, kind of like on the more like advanced side of things, right? You're probably not going to use this that often, but you know, this is a way you'd solve it really easily. If I put these points into Desmos, you see, I can ask Desmos to like literally tell me what m and b are for this equation, right? So the way you type in a custom regression is you're going to replace y, which is this g of x, with y1. And you're going to replace your equal sign with a tilde, right? And then you're going to replace x wherever you see x with x1. The reason we do that, you see in the table, it says x1, y1. So we wanted to use the table. So we write this in, you see x1 plus 3. And it gives me my m and my b, and so I know it's 36, right? Easy if you kind of know that. Next one, circle G. A circle has center G. M and N lie on the circle. MH and NH are tangents. Okay, so I've seen this question before about tangents, right? You need to know like how to draw a circle with tangents, because if you know that, you know, that's one part done. It makes it easy. So it would be like this, right? Tangents just touch the circle at some point, right? So it could be something that looks like this, right? So it's just touching the circle here. They said at M and N, and then they said the center was G, right? So it would look something like this. You know, those are our points. And H would be out here where these two tangents meet, right? So again, I've seen a problem like this before with tangents. So I know what the picture should look like. So that gives me an advantage. If you don't know that, then it's going to be a tough problem, right? Especially with time winding down in module 2, right? So that's why, again, just you need to do enough practice that things are instantly recognizable to you, right? So where you're going to get that repetition, sigmaprep.io, right? Get practicing, right? And then there won't be any surprises. So what do we know now? Okay, so they tell us the radius is 168, and this is the perimeter of quadrilateral. GMHN is 3,856. Okay. So let me plug some of those things in. So you see, this would be the radius. So we know this is 168, and we know this is 168. Here's also something you want to know about, you know, these tangents, is that they're going to be congruent to each other. We can prove that through proving triangles congruent, but you should just know it. So you see, this tangent's going to be actually the same length as this one, right? And this is where the whole perimeter thing comes in, right? Because now this is my quadrilateral. I can add this up, and they told me what the perimeter is, right? So let's do that. We'll do 2 times the 168 plus 2x, right? And it has to equal 3,856. Zoom out, and you see, we figure out what x is. So be careful, that's not your actual answer in this case, right? Because the question wants to know what's the distance between G and H, right? What we found was these two. GH, if I want to draw that, it's going to be this, right? One other thing I forgot to mention that's important about points of tangent is that this point of tangency on the circle, M and N, it forms a right angle, right? So these are going to be like right angles in this case, right? So the reason that's important is that's going to be how we figure out like this final piece, right? So we know that that this number over here was 1760, right? And we know this was 1760. You just do a Pythagorean theorem, right? If we want to now, let's call that our x, right? If we want to figure out what that x is, you're just doing a Pythagorean theorem. And you can do that in Desmos. 168 squared plus 1760 squared equals x squared. And there's our answer, right? It's just going to be 1768 instead, right? So that's it. Last question here. Function f is defined by this quadratic in standard form. The graph passes through the points 7, 0, negative 3, 0. If a is an integer greater than 1, which of the following could be a plus b? Wow, so some tough ones actually tend this one. I think this is honestly a pretty tough test. Quadratics, you need to know your quadratic forms. Each form tells you certain things, right? Standard form, that's what we wanted to be in. But you see, we're going to start in vertex form because they're telling us the x-intercepts, right? So you see, what I do is first I kind of write this in its factored form, right? So it'd be like x minus 7 for this x-intercept, and then x plus 3 for this other one, right? And so then I wanted to be in standard form, so I got to FOIL this out, right? So if I FOIL that out, it's x squared minus 4x minus 21. And you see, then I can distribute the a, and I get minus 4ax minus 21a. Their question is, it tells us if a is greater than 1, which could be the value of a plus b? So this is an interesting question, could be question. Could be questions are interesting because like what that means is there actually could be infinite answers, but what they're saying is which one of these answer choices could be correct. So what you got to do is you got to meet in the middle with like your answer choices, right? So you see, my a over here is a, my b over here is negative 4a. So if I did a plus b is going to be negative 3a, right? This is saying answer choice A is saying negative 3a could equal negative 6, right? And so if I solve for that, you see, I get a is 2. And I know that's correct because you see, they told me a is greater than 1. Whereas like if you solve it for any other one, right? Like if I solve it for b, that it equals negative 3, that would give me a is 1, which is not greater than 1. And if I had c, like that would give me negative 4/3. So that's not greater than 1 and it's negative, right? So that's why it has to be a, right? But a is not the only answer, right? Like literally any like negative 7, negative 8, you know, like use any number smaller than that and you'll get a value of a that's greater than 1. That's why you can't like solve for it directly. You got to kind of use those answer choices in these could be questions. So that's also kind of more advanced thing, right? And that's it. That wraps it up. Did we miss a question? Oh, wait, we missed. No, we did it. I just didn't select it. Okay, so got it. That should be all of them. So that wraps up module 2. Let's check out the score, see how that turned out. But yeah, honestly, pretty predictable, but there were some tough ones, right? But go to sigmaprep.io, grind out the hard problems, right? You'll be ready for all of that, right? You should walk into the test and know 95% of the questions, right? Maybe there's going to be like 1 or 2 that you don't know, but you should be able to relate it to something you have seen then, right? And you should still find success. So let's check out the score. And that's another perfect 800. Here's the thing. Every single problem on this test follows a pattern. Once you've seen that pattern enough times, you stop solving and you start recognizing. That's the difference between a 600 and an 800. If you want to build that same kind of recognition, sigmaprep.io is where I'd start. Practice problems by topic, video explanations when you get stuck, and enough volume to make the real test feel like a review. Like the video, subscribe to the channel so you can catch the next speed run.